Example 6 in examples class 1 is the standard deviation example for the post office, or the post shop if you prefer. And remember, the standard deviation is a measure of spread. It measures how far on average individual observations are from the mean. So it's a measure of variability. It's a very common measure. We use it in statistics a lot. It considers how the data are distributed, and it measures the deviations from the mean. The example itself, waiting times in minutes of customers at the local post office vary dramatically. A sample of 5 customers gave the following data in minutes: 3, 5, 7, 9, and 11. Find the mean and the standard deviation of these values. So n in this example, the number in our sample is 5. N is 5. You'll recall these formula from lecture 2 when we looked at the steps covered to find the variance. We'll remember that the variance is the square of the standard deviation, or the standard deviation S is the square root of the variance. So S squared is the variance, and S, which is the square root of the variance, is our standard deviation. The steps to find the standard deviation are, we first of all have to find the mean, x bar. We're looking to find the mean because it measures the deviations away from the mean. So we'll be taking each value, each observation, and subtracting the mean away to find those deviations. We'll be squaring those. We square them to get rid of the negative numbers. So squaring them and then dividing by the number that we have, n minus 1, to get our variance. And the last step, square rooting our variance to get to our standard deviation. The steps covered in lecture 2 for finding the variance. So to return to the example, the raw data, 3, 5, 7, 9, and 11. Calculate the mean, x bar. We're going to add the values together and divide by n, which is 5 for this example. 3 plus 5 plus 7 plus 9 plus 11 divided by 5, a total of 35 divided by 5 gives us a mean of 7. 7 minutes for the mean. Now to cover the steps in the standard deviation, the easiest way is to draw up a table, as we saw in lectures. So we're going to list the values of our observations, our values of x, 3, 5, 7, 9, and 11. Then to calculate the deviations away from the mean, our second column, x minus x bar. Our x bar, our sample mean being 7, we need to take each observation and subtract 7 away. So 3 take away 7 will give us a value of negative 4. 5, negative 7, giving us a value of negative 2. 7 take away 7 being 0. 9 take away 7 being 2. And 11 minus 7 being 4. So those are our deviations. Next step, to square the deviations to remove those negative numbers. A negative number squared becomes a positive number. So squaring the previous column, negative 4 squared is positive 16. Negative 2 squared is positive 4. 0 squared remains 0. 2 squared is 4. And 4 squared is 16. We've got the squared deviations. The sigma in the formula tells us we need to add those up. So adding up that column, the sum of all the deviations squared, the 16 plus the 4 plus the 0 plus the 4 plus the 16, a total of 40. The sum of the squared deviations is 40. So our standard deviation, the square root of the 40 divided by n minus 1, remember, for sample standard deviation, n minus 1, so it will be 40 divided by 4, n minus 1, n being 5. So 40 divided by 4 will give us 10 for our variance, and the square root of 10 will be our standard deviation. Square root of 10 gives us a standard deviation of 3.16 to 2 decimal places.
Get rid of the s squared.
And just remove that s squared. The standard deviation for this example, 3.16 to 2 decimal places. And that's our standard deviation example